Hey, what's going on guys? Komaki here. In this video, we're gonna code Hello World in machine codes under GameOS, an operating system which I've developed to code in x86 machine codes using hex editor to input them. And also I've added some lookup tables for opcodes and for ASCII characters. So all we need to have is just bundled into a single flash drive. Um, there is uh, an operating system image basically. So I just started the computer and let's have a look. So I'm running this on a real hardware. This is my good old Asus laptop. Okay, there might be a bit of an issue with with an autofocus, but no, it works perfectly well. So let's adjust the color scheme so you no longer see the reflection. So let's go for a dreaded Windows blue screen theme. Okay, and let's go to the editor. So here we're gonna be writing our Hello World program. So all we need to do is just to turn the assembly language from assembly syntax, from manual syntax. I'm gonna be using that because I used to work with that, to machine codes. But the syntax doesn't really matter that much because we're gonna be kind of like we're going to input the machine codes, so it doesn't matter really. So if we go to tables, here we have ASCII tables, and yeah, I just need to fix the layout on the table a little bit, but yeah, I'll do it later. And also tables and the opcodes. So all we need to generate opcodes from things like this, like move si, and then the certain address, right? Like 0x uh, 0500, for instance, like this one. So we can actually um, generate, we can turn this to machine codes, right? But let's start with just going and let's start with returning from shell from the F first. So just get away from here and go into edit. So if I do nothing, if I just run, I stuck forever. So I would need to turn the computer off and turn it on. So just to show you that if we do nothing, it just jumps to 500 hexadecimal in the physical memory and stacks there forever. So let's start from the very beginning again. So dreaded blue screen. And now let's go to the editor, and let's say at this address I can enter. Well, I just know that by heart already. So let me just demonstrate how we can avoid stuck forever and just jump back to the shell. I will break down this code a little bit later on. Okay, for now I just want to show you that if we did input some sort of a machine code, we have it running, right? And now, so yeah, let's also try to print a single character. So let's erase what we currently have there. All right. And now let's go back to tables and opcodes. And what I want now, so I want to say move to AH0x0E, which means BIOS code for teletype output. So let's convert this. So we have move command and immediate value right over in here. So B, then W is going to be 1 if we're dealing with 16-bit registers, or 0 if we're dealing with 8-bit registers. So we have 0 here. Okay, then the register is AH, so the code for AH is 100. So 100, and then the value 0E, this is the value, so just 0E. Okay, so let's convert this to machine code. So B, then 40E. And this is machine code that we need to input in order to make sure that we actually output a character. So let's go back to the editor, and let's say I say 0500, and I put this code B40E and enter. So we got the code, so it's in the it's in the random access memory now. Okay, now let's go back to tables. So we need to initialize the character next. So in order to do this, I need to say move to AL. I want to move, let's say, character A, but we need to use the hexadecimal value, which is, I just know that this is 61. If you don't trust me, we can just go to tables and ASCII characters. So let's look for A, and this is the value of 61. All right. So again, tables and opcodes. So we want to say move to AL. We want to move 0x61. So same scenario. So we're moving the immediate data. So here is the format for instruction. So B, again, W is going to be 0, the register. So then we need the register. So the register is AL. Now this is going to be 0, 0, 0. Okay, and then the value, hold on a sec. Oh my god, hold on a sec, BW. Yeah, then the register. Yeah, and then the value, that's okay. And 61 in our case. So 61. Let's convert this to hexadecimal. So this is going to be B061. And now until we are here, so we need to call BIOS interrupt 10 hexadecimal. So interrupt has opcode CD followed by whatever we want. So CD10 is just to output that character. So now let's go back to editor 05. I need to skip 2 bytes, so 05 0 05 00 1 2. So 0502. And now let's type this one. So we want to move A to AL. So B061 and then CD10. And then we can just go back to shell. So EA 004008. I swear I will explain how this jump works. That's just the for jump, nothing special really. And if we just now type run, then it should print A and go back to shell, which it does. Okay, but we're not going to be doing we're not going to be printing like letter by letter. It's not the best ever thing, so we'll write a real program. Okay, so yeah, we just can store those opcodes that we need. So let's go for that. So I can say 0520, and I'll just just need to go to the editor, and I just store them like in the second line, not just to avoid composing them from scratch again. So we have B. Okay, sorry again. Edit 0520. Okay, so B40E. Okay, so this moves 0E to AH. Then we have the second one we don't need. We're not going to be using that. And CD10 to print. All right, and now 0500, and we can just erase what we currently have there. And now let's save. All right, the first one. Okay, now it's not going to be working, right? But now we need to do the following thing. So let's initialize the hello world string right over in here. Okay, and then we'll point SI register here, and then we're going to be using load single byte to initialize AL, and we're going to be printing that in a loop. Okay, just like a regular hello world in assembly. Okay, so now we need to get the ASCII characters. So for hello, so I go to tables and A, and now I need to grab, so hello is, let's find, so I'm using hexadecimal, so H is 48, E 65, L 6C, 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 and O 6F. So it's enough for now, 6F. Let's just be happy with this. We'll add comma, world, exclamation mark, and new line and carriage return later on. Okay, so going back to the editor, and now address 06 E0. So this is where we're gonna be writing our string. So here, and I just input the bytes, so 48, then 65, and in ASCII, I do input this ASCII characters, nothing special, 6C, 6C, 6F, and we're done. Okay, okay, so seems like it's okay. Now let's save to make sure. Okay, so if I break something, we can restore. So not going to be doing this again. And now the next thing we want to do is to point the SI register to this exact address. So let's now go and do that. Okay, so I'm going to the tables and opcodes. So what I want to do is move to SI. I want to move the address. So yeah, I forgot the address. So let's drop back. Edit. So address is 06E0, 06E0. Oh, I shouldn't be doing this. Okay. Edit. Okay. 06E0, tables, 06E0. 06E0. Okay, so again we have the same scenario where we want to put the immediate data to register. Okay, so again B. Now W is going to be 1 because SI is 16-bit register. SI here. Then the register itself. So SI is 110. So 110, and then the value, so I can't say 06 E0 because this is the big endian byte order, but we need the little endian byte order, and this would be E006. Okay, and eventually it would be BE, then E006. Okay, so this is very important. So let's put it to the editor now. Okay, so just hit enter and go back to editor. So now 0500, the very first instruction would be this one. So BEE006. And I just get done with this for now, all right? So just store it. And what else? What do we need to do next? So we need to put 0E to AH once. Then we need to load single byte, print it. Then we need to compare it. Well, okay, let's just go step by step. So the next thing is to put this value, okay, the next one. And then the step after is going to be to load the single byte. So let's just have a look at the tables and opcode. So we see the load single byte is AC. So we're going to put this just right after. Okay, so going back to editor, 050, and now hold on a sec, 0, 0, 1, 2, 3. Okay, now I need to move 0E to AH, so B40E, Okay, then I need AC to load single byte, which we just had a look at. And then we want to print the characters, so CD and 10. Okay, and the next thing to consider would be to actually jump to uh, to AC. Okay, so let's make it first. So then we need to jump to uh, to AC here, right? In order to uh, move the pointer where size points to print the next character. We'll also need the escape condition. So when we hit 0, we just escape. But first, let me demonstrate how we just print everything what is available in the memory from here and just to the very end. Okay, so let's go back to the tables. And now we need there are two ways of how we can do jump. So we can do like relative jump, this one, but going backwards is a bit too complicated. So instead we'll use um, this jump, which is actually a far jump, but we still can make use of this far jump. So all we need to do is to calculate the proper address. So let's first focus on calculating the proper address. So let's go back for now. So here we have, we're going to be using the address like specific for far jumps. There is a formula to calculate it. That's a bit of a different story. I just don't want this video to last forever. So we need this address, and then we need to add the offset of 1, 2, 3, 4, sorry again, 1, 2, 3, 4, and 5. And then instruction pointer would get here. So we need this address and offset of 5. Okay, so going back to tables, so opcodes. So the far jump in assembly would be like this, 0x. Now I use 50, not 500s, because to calculate that, we multiply by hexadecimal 10, or decimal 16 and plus the offset. That's the formula for far jumps. So here is the segment, and now we need to calculate the offset. So offset is going to be 5. And now let's encode this. So we have EA, okay, for a far jump, EA, and now all we need to do is to put this address, so 50 0005 in the little endian order. So this is gonna be 05, 00, and 50. And this is pretty much all about it. All right. So okay, so my camera is not that great. Sorry, let me just adjust this. It's incredibly unhanded to work like this, but I really wanted to show you this in a real hardware, guys. So hope it's gonna be okay. All right, so go back to the editor and EA050050. So we now put it here, and this is going to be an infinite loop where we're stuck, but anyway, 050, and now calculate the offset 0, 1, 2, 3, 4, 5, 6, 7, and 8. 08, and we just put our EA 050050. Okay, and we hit enter, and here I want to save as prog1. All right, and I hold my breath and run, and now it should print everything in the memory, which it does. Cool, but yeah, we need to reset the computer because yeah, it's not going to be working that nicely. So it works as a proof of concept. So load single byte works where the pointer where SI points is getting incremented, so everything is cool. So now we need to add a condition. So the condition is gonna be the condition. Are you kidding me? Come on. All right. So if AL is equal to 0, we want to actually drop, we want to drop back to the shell. That's pretty it. So now I load app1, all right. Edit, so we still have this, okay. So now we want to remove this part, okay, but first let's get the code for compare. So tables, opcodes, and I want to say compare AL with 0. That's it. So code for compare, so we have 8 hexadecimal, then this should be, so this is 3 zeros because it's like 3 bits represented by 1 decimal bit, by 1 decimal digit, but 3 bits here, so it's 0, 0, 0. For instance, here it would be 0, 1, 1, here it would be 0, 1, 0, right? But here it's just 0, 0, 0. Then W is going to be 0 because AL is 8-bit, so 0 here, okay. Now for compare, compare with immediate, so 1, 1, then instead of the question mark, we put 1, 1, 1, 1, so 1, 1, and I will group, it's already grouped this by 4 in a chunk, 4 bits in a chunk, and then, hold on a sec, then the register, then the register, and the register is AL, which is 0, 0, 0, and then the value to compare with is 0, 0. Okay, so, and this one is hexadecimal, obviously, as well as the first 8. So we have 8, 0, F, 8, and 0, 0. Okay. So now let's go back to editor, and anyway we need to put this instruction just instead of this one. So 050, type in the address 0, 1, 2, 3, 4, 5, 6, 7, 8, so 8, okay, 8, and now I input this one, so 0, F, 8, 0, 0. Okay, and just to make it easier to calculate, I just put this FF, so it's visually seen better. Okay, so we got it 0, or hold on a sec. Yeah, CD10, 0, CD10, 8, 0F, 8, 0, 0, and yeah. And the next thing to consider, we want to have, so if equal, we want to jump to a certain location. We don't know how many, so that would be the relative jump. So, well, anyway, let's get the opcode for that first. So tables, and go in there, and so conditional jump, conditional jump. So 0, 1, 1, 1, 1, 1, and it's going to be 7. So once say jump equals to, not sure how many, what would be the offset for now, but let's say offset. So this is going to be 7, okay. And then TTTN, and we look for TTTN here. So jump equals 0, 1, 0, 0. 0, 1, 0, 0, which is 4. So this is going to be 74 plus some offset. So yeah, we still can use FF instead of the offset. Okay, so now let's go back to the editor and 0, 5, 0. Now let's calculate the offset. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold on a second, just. Oh, guys, yeah. Hold on a sec. Yeah, I'm sorry. This is actually a little bit wrong because we actually want to compare not after printing, but after after AC. Okay, so we'll now move this constant here, and then we'll make CD10, and no, and then we'll put our jump equals. So yeah, bear with me. So 0500. Okay, edit 0500. Right. 0, 1, 2, 3, 4, 5, 6, 0, 6. Oh, 0506. Okay. And now this constant. So I have F0, F8, 0, 0. And then I'll have 74 and let's say FF. So jump equals and where to jump. We don't know where to jump yet. So, okay. Okay. Yeah, now should be recognized as in the offset. So this should be A. So let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A. Okay. So A, so starting from 050B, we're gonna input the further stuff like, so we need then to CD, okay? So actually I say 050 B and CD10. So if it's not equal, then I want to print the character, okay? And then I want to restore my code to jump back to this AC. So I just remember that by heart. So EA 050050. Okay. So here is the offset. Okay. And now, so we'll skip 50. We'll skip 2 bytes and then we'll put our condition to escape back to the shell. So we have so this is A, B, C, D, E, F, hexadecimal 10, hexadecimal 11, hexadecimal 12. So 0, 5, hexadecimal 12. And here we say EA 00000008, which is the code to drop back to shell. Okay. Now we can clear 05 this one because we no longer need that. And now let's save. Okay. So now the only thing left here is to calculate the offset. So just to give you an idea, what am I doing here? So if I go back to tables and opcodes, so here we have an 8-bit displacement. So 8-bit is 1 byte. So we need to count how many bytes we need to skip forwards in order to jump to the instruction that would bring us back to the shell. Okay, so going back to edit, and now, so this is A, B, so A, and now counting, so 1, 2, 3, 4, 5, 6, 7, so 7 bits. So at 050A, I need to put exactly 7 bits, hit enter, okay, So now we have 7407, which would bring us right over in here. And if I did everything properly, we'll then jump back to shell. So let's save. Let's save. And I hold my breath and type run. If I did everything properly, it now should print hello and then drop back to shell. And this is exactly what it does. And to be honest, guys, it took me around 4 hours to make it work when I was debugging before recording this video, but this is really worth it, and this is so satisfying. Okay, so the very last thing we need to do is to add a bit of ASCII characters. So we have the comma, world, exclamation mark, new line character, and carriage return. So let's go to ASCII, let's go to tables and ASCII, we need ASCII this time. So so we need the comma. Comma is 27. Okay. Now W 77 O 6F R where is R? 72 war L 6C and the D 64. Okay, then we need exclamation mark 21 and then new line character 10 and carriage return 13. Okay, so going back to editor, now we need to address 06E and the offset is 0, 1, 2, 3, 4, 5. Okay, and now I need just to type this ASCII characters, and that's pretty much all about it. So 27, 77, 6F, 72, 6C, 64, 21, 10, and 13. And hit enter, and I really hope it gets exactly here. Yeah, which it does. So save. All right. And I hold my breath, and oh my god, I did save to the wrong place. Sorry. Save to 1. Oh, what have I done? Oh, save. Oh. Now my USB flash image is malformed, but doesn't matter. Okay. So let's now run. And we have, well, something has got wrong. We have hello world. We do go back, but something is wrong with the last 2 bytes. And also, oh, we have a run. So it wasn't a comma. It was a single quote, I believe. Okay. Well, actually, this is okay already, but I'm really wondering. So yeah, let's go back to shell. Let's go back to editor. So 66F, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, hold on a sec, guys. Okay, so I just now I did put this to the paper, so no need to extract them from back from the ASCII table. So if something goes wrong, I will just type them from paper. Okay, so we stopped here. Hello, this is O. So we need 06 E0. And well, guys, I just thought that probably this might be because I could have write. Hold on a sec. Actually, everything's still working. Okay. Load 1. Okay. 06. This is wrong. 06E 0 1 2 3 4 5. Okay, so comma is to C. Okay, so yeah, I'm just typing from the paper. I got it here. Here are the ASCII characters, right? So 20 77 6F 72 6C 64 2 1, and I try again. 10 for new line character and 13 for carriage return. I have no idea why this doesn't work. It should actually, so let's save. And yeah, for some reason, okay, go back to edit. 06E 0 1 2 3 4 5 6 7 8 9 A B C. So starting from D, so just put it on paper. So 06 E D D. If I just put nothing there, yeah, so hello world is typed okay. I'm really confused, guys, to say at least. Like why it doesn't. So well, let's save as the best so far that we have. Okay, so edit 06 ED. Let's try 10. So it won't return the carriage, but no carriage return, but at very least it should type a new line. I'm really confused why this is not working, to be honest. The codes should be fine. I have no idea. And I do compare with zeros, not with anything else, so it's really strange. Okay, run. Yeah, and it just types some gibberish instead. I'm not sure exactly, guys, why exactly this is happening. Well, okay, let's try to reload. Maybe I just has broken something. I don't know. When I was saving, I typed the wrong button twice. So, well, but in that case, I could just malform the USB image, not nothing else. Okay. Load 1. Zero 06 ED 10. Yeah, I don't know what's going wrong, guys. Okay, so just hold on a sec. Well, okay, guys. So yeah, unfortunately, I didn't manage to get this new line character and carriage return working. This is very weird, and to be honest, I have no idea why exactly this is happening. But anyway, we did manage to print a string, and we had a conditional operator, like compare, like we had a loop, jumping back to from here to loading single bytes, so which results in incrementing where SI is pointing to. So from here to here, here, and every next time AL contains the value, and then using the CD10 we just print the value. And that's why this is so mysterious to me, because CD10 should just, you know, like print whatever we have in AL. And if AL actually gets that, if it gets that 10, right, then it should be just fine. So I don't know. I need to clean up my image. Trying to run this again to see where is the problem. So whether I've ruined something during recording the video, or maybe there is some sort of a bug. But this is really strange because, you know, like all the characters are getting printed properly, but the new line character and the character return for some reason don't. So yeah, it's really unclear to me why is that happening. But I have a work to do now, guys. So yeah, that's kind of it. But anyway, I think that this is quite pretty successful attempt. So this is my very first time live coding in machine codes. And even though, yeah, I did have some prepared codes here, right? But that's just for verification. You saw, guys, like actually I've been composing them using these opcode tables. So all the data we have here allows to come up with the certain opcode. Okay, so yeah, this is it from my side. So thanks for watching. Until the next time, and take care.